I want to give you two additional examples of finding a matrix that represents a linear transformation. The first example is L takes R4 to R3, and I want to use this basis for R4, which you can see I have a 1, 1 that I just kind of moved down, except for in the last one I put a -1 at the top here. And I want to use this basis for R3. So 1, 0, 0. Here I multiply E2 by a 2, and then -1, 0, 1. And here's the linear transformation. I take the last entry in this column vector, put it here, and then also the negative of it here, and then I add these three entries together. So a good exercise is to prove that this is actually a linear transformation. But this is what I want to find. I want to find this matrix. So let's recall what this matrix actually looks like. What do? We take this basis right here in the order that the basis vectors are presented, and we plug each one of them into L. And then once we plug these into L, we write them in terms of this basis, the one in the front. So what we need to do is we actually need to calculate what happens when I plug these basis vectors into L. After we do that, then we write it in terms of the basis vectors for R3. Okay, so let's do that. Let's start with 1, 1, 0, 0. Let's see where that's sent. Then we'll do 0, 1, 1, 0. Then we're going to do 0, 0, 1, 1. And the last one is -1, 0, 0, 1. Okay, for the first one, let's look back at the linear transformation. For the x4 term, I have 0. So this is 0, 0, and then add these three together, I get 2. Great. Now plug this one in. Again, we have 0 for the x4 term. Then we add these together, we get 2. It's interesting, we got the same vector here. All right, now we're going to plug in 0, 0, 1, 1. Well, x4 is 1. Add these together. Okay. And then for the last one, we get 1, -1, add these three together, I get -1. Great. Now that I have these vectors, I'm going to write them in terms of the basis for R3 that I chose. So this is equal to an alpha1 times, well, let's look back at that basis. Here it is right here. 1, 0, 0 plus alpha2, 0, 2, 0 plus alpha3, -1, 0, 1. Okay, what are these alphas? Now, one way we could solve this is we could put these as column vectors in a matrix, an augmented matrix, along with a line, and then we put on the right side of that line the 0, 0, 2, find the reduced row echelon form, and we would be able to solve for alpha1, alpha2, alpha3. That takes a little bit of time. Maybe we can just reason through this to get to the answer quicker. first off, the only thing I need is this 2, and I need it in the last entry. So notice the only thing non-zero in these basis vectors is this 1 here. So that means this alpha 3 has to be a 2, because that's the only way I'm going to get a 2 here. So when I multiply this one by 2, I get a 2 and a negative 2, and I want a 0, so I got to get rid of that negative 2. That means that this alpha 1 has to be a negative 2, positive 2, sorry, because that's 2 and that's a negative 2, so they cancel. And this alpha 2, this only gives me something in the middle, and I don't want anything in the middle, so let's erase that and put a 0. Okay, so we figured out that this one right here is 2, 0, 2. And what's really nice about this is this vector here is the same as this one. So this column vector here will also be 2, 0, 2. So let me just copy this. Because this is the same. Oops. And I'm going to put this in red. 2, 0, 2. Okay, how about this one? Maybe we can figure this one out quickly as well. Okay, so I need a 1 in the bottom. That's how I'm going to figure this out. That means this one has to be a 1. But then I get a negative 1. I need to get rid of that. Now, actually, I need to make it a positive 1. So how do I make this a positive 1? If this is a negative 1, well, then this one has to be 2. Because then I'll have 2, 0, negative 1. So it gives me a 1. And then I get the 1 down here. But I need the middle one to be a negative 1, so that means that this has to be a negative 1/2 to cancel that 2. Okay, great. So I figured out the third column. And then for the last column, let's see if we can solve that. I need a negative 1 here, so this has to be a -1. Okay, that makes a positive 1. So then this is 0, 0, positive 1, negative 1, and then this needs to be a negative 1/2. Okay, so I have all my columns. So let's write them out. L, in terms of these bases. Well, the first one is 2, 0, 2, then 2, 0, 2. The next one is 2, negative 1/2, 1, and then 0, negative 1/2, negative 1. And I found the matrix that represents the linear transformation in terms of these bases. So how can I double check this, or what is a question that your instructor could ask you to verify that this is the matrix that represents this linear transformation? Well, I could give you a vector in terms of R4 and ask you to apply L to it, and then you'll get a vector in terms of R3. I would ask you to write these vectors in terms of these bases, so write the coefficient matrix, and multiply this matrix by the coefficient matrix with respect to this basis and see if you indeed get the right answer. So let's just do that as an example.